Unit 8, we're going to start with variation functions. We're going to solve problems involving direct, inverse, joint, and combined variation. First off, a direct variation is a relationship between two variables. It can be written in the form y equals kx. K is called the constant of variation. For this equation, y equals kx, y varies directly as x. So a direct variation equation is a linear equation in our form y equals mx plus b, where b equals 0, and k, constant of variation, is the slope. So the graph will always pass through the origin. So let's write and graph a direct variation. Y varies directly as x. So the first thing we do is write the generic form of direct variation, y equals kx. We use y and our x to find k. So we divide by 3.5, and k equals 4. And then rewrite our direct variation and graph. You could use Desmos for that. I know it passes through the origin, or you just plot some points. So when x equals 1, y equals 4, x equals negative 1, y equals negative 4. And plot points. So we'll check it out. First step is always to write our generic form, y varies directly as x. Then substitute our y and our x to find our k. Divide by x. 6.5 divided by 13 is 0.5. And then rewrite our direct variation. X is 0, y is 0, x is 1, y is 0.5, negative 1 is 0.5, x is 4, and negative 4. When you want to find specific values, you can solve for k, then use substitution, or you can use proportions derived below. And I will show you in the next problem how to use the proportion. So we have circumference C varies directly as the radius. C varies directly as the radius. C equals 7 pi when R is 3.5. So the first thing we have to do is find k. So we divide by 3.5. 7 divided by 3.5 is 2, so k equals 2 pi. So C equals 2 pi r. Then use the new situation. Find r when C is 4.5 pi. 4 4.5 pi divided by 2 pi. Using the proportion method, we would use C1 over R1 equals C2 over R2. So C1 is 7 pi, R1 is 3.5, C2 is 4.5 pi, and I'm trying to find R2. Cross products are equal. And then divide by 7 pi, and you still get 2.25. I don't typically use that second method, but you are more than welcome to use that. Perimeter varies directly as side length. Perimeter is 18 when the side is 1.5. Find S when the perimeter is 75. And the units would be inches. Okay, joint variation is when we just have a relationship among three variables. It's written in the form y equals kxc. Again, k is constant variation. Okay, and it's in words said y varies jointly as x and z. Okay, so in this first one, the area varies jointly as the base and the height. The area is 12 when the base is 6 and the height is 4. So we find k. And then we use our variation function, which is area equals 0.5 base times the height to find b when the area is 36 and the height is 8. So trying this, we have lateral surface area L varies jointly as the base radius and the slant height. We find K. And R is 3.5 and the slant height is 18. Oh, I forgot the pi in there, sorry. And then L equals pi r first of L. So our new lateral area is 8 pi. Trying to find R. L is 5. So you divide, pi's cancel out, so you get 8/5, which is 1.6 meters. That does end the first day. I am going to continue with the video if you want to continue with your notes. Another type of variation is, or will describe when one quantity increases, the other decreases. This is called an inverse variation. It's written in the form y equals k over x, and it's in words, y varies inversely as x. So, writing and graphing these. If I'm doing an inverse and I'm in y equals k over x form, same as before, we try to find k when y equals 3 and x equals 8. So multiply, then my new or generic form, and if you plot that in Desmos, and these graphs aren't quite big enough, you will get x is 4, y is 6. These curves. Something like that. So again, varies inversely. It's k divided by x. Y is 4 when x is 1. So my k is 4. Oh, this was cut off. I'm sorry. Should have been at 10. And this is off the charts. When x is 10, y is 4. And okay, so when we this in a, what I'll say, proportion type form, we end up with multiplication, and I will show that in method 2. Okay, so time it takes a group of volunteers to construct a house varies inversely as the number of volunteers. 20 volunteers can build a house in 62.5 hours. We find k by multiplying. Generic form. And then it says how many volunteers if it takes 50 hours. So 50V equals 1250, so we'll end up with 1250 divided by 50, which is 25. Using the other method, which is multiplication, we know it takes 62.5 hours for 20 volunteers. How many volunteers if I want to reduce it to just 50? Let me see, we get the same answer. Once again, I have a tendency of just following method 1. So you are more than welcome to do either method. So how many working hours would it take if we only had 15 volunteers? So I already know my generic form for that original situation. Substitute in 15 for V. Dividing, you get we can also rewrite in terms of K, and this will allow us to determine from a set of values if we have a direct or inverse variations or no variation. So if I rearrange my direct variation for K, I get Y divided by X. Okay, that will be a constant ratio. And if I rearrange in my inverse, my K is going to be a constant product. So when you're given data and you want to determine if there's a variation, you see if you have a constant ratio by dividing them, Y divided by X, or do you have a constant product, multiply them. So in my first example, if I take and do X times Y, you can see I get 27 here, 192, 300. It's not constant. But if I do Y divided by X, 9 divided by 3 is 3, 24 divided by 8 is 3, 30 divided by 10 is 3. So I have the constant ratio. So this is a direct variation. So in the second one, if I do a product, 8 times 4.5 is 36, 3 times 12 is 36, 18 times 2. So I have a constant product, so this is an inverse. Okay, so you do that with your set of data. You test either as a product or as a ratio. Remember that the ratio or the division is the direct and the product is the inverse. Sometimes you can look at them and see which direction you want to go. I know 3 times 15 is 45 and 9 times 5 is 45. I just test this one and this happens to be 45. So I have the product. Product is an inverse. I test the product here, I get 0.2, I get 320, that's not going to work. So I test division, I get 0.2, 0.2, and 0.2. So this is an inverse. A combined variation will have both. We'll have a direct and an inverse. And Remember, the direct is going to be a multiplication k times x, so that's going to be in the numerator, because an inverse puts that x in the denominator. So looking at this application, and gas laws is a excellent example of inverse and direct variations. So we have the volume of gas varies inversely as pressure and directly as temperature. So the pressure has to go in the denominator, temperature in the numerator. We find our K with our given information, which I have a volume of 10 liters when the temperature is 300 with a pressure of 1.5. So you can take 1.5 times 10 is 15. Divide by 300. So my variation function is going to be volume equals 0.05 T divided by pressure. It says if the gas compressed to a volume of 7.5 when it is heated to 350, what's the new pressure? So you would take 350 times 0.05 and then divide by 7.5, and you get 2 1/3, and this is going to be in atmospheres. Units I'm not going to be as particular about. And trying one more. If the gas is heated to 400 K, so we're using the same variation function that we just created. And I'm trying to find volume when the temperature is 400 and the pressure is just 1 atmosphere. Okay, in closing the lesson, we're just going to write some of these variation functions. So this would be, first one would be D varies inversely because it's in the denominator as M, and that's our K. 7.3 is our K, so this is D varies, and I have more than one variable, jointly as S and T. Pi over 4 is our constant, so this is a direct varies directly as P. 8/3 is our K, so this is a combination. D varies directly as G and inversely as H. And this ends 8-1.